In this video, I want to look at the distinction between how the trig ratios are defined based on whether they come from a free-form right triangle or a right triangle on a circle. Okay. So let me just put that in here. All right. So what I mean by that is, if you're on a free-form triangle, what that means is that triangle, that right triangle, all of these definitions are for the right triangle only. That right triangle can be in any orientation. So for example, let's say I draw a right triangle like this, and here's my right angle, and it's understood that we have a perpendicular angle here, and so this is 90 degrees, and across from it then will always be the hypotenuse. And then you have to say whether you're going to label this. It really depends on what angle you're naming everything relative to. So for example, if I want to say this is alpha and then that this is beta, then relative to alpha, this is opposite here and this is adjacent. But relative to beta, this is opposite and this is adjacent. Right? So that's really important. And if you'll recall, what you have for definitions then is right here. Cosine is adjacent over hypotenuse, sine is opposite over hypotenuse, and so on and so forth, right? So those are just your definitions, and I went into this a lot more lengthy explanation in the video, similar triangles to trigonometric ratios. But I just want to make sure you understand that this is for a free-form triangle. And I could flip this in any way, right? Now, so I could have written it, let's just say here. I could have done this. And let's say here again is my right angle. Here's across from it is hypotenuse. And then maybe, let's see, let's just say this is alpha and this is beta, right? Say it's the same triangle, but I just moved it around. I just went like that. So again, you'd have opposite here, adjacent here, relative to alpha. But relative to beta, this would be opposite, and this would be adjacent. Okay? Now that's on a free-form triangle. When we talk about these other definitions for the 6 trig ratios, which go to x, y, and r, that comes from having an angle in standard position. But an angle in standard position says that essentially you're here at 0 degrees, your vertex starts at the origin, so this is the initial side always. Always, always, always. It's on the x-axis, on the positive x-axis. And then you rotate a certain amount, and then wherever you finish rotating, that's your terminal side. And then what you do, the rule is, you drop a perpendicular to the x-axis, and now here's your angle, and this is always going to be opposite, adjacent, and then hypotenuse. But because of this rule where you drop to the x-axis always, 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 then it will, and this is the angle in standard position, which is between the terminal side here and the x-axis, then relative to this angle, the opposite will always be y, the adjacent will always be x, and your hypotenuse will always be the radius. And it doesn't matter what quadrant you're in, this will always be true. So I'll just do this, for example, in quadrant 4, just so you can see it. Suppose I start in here at 0 degrees, and I'm in standard position. By the way, this is your x-axis and your y-axis, x-axis, y-axis. And let's say I rotate all the way out to quadrant 4. Here's my terminal side. I drop my perpendicular to the x-axis. My angle, even though this is the rotation, the reference angle is between the terminal side and the x-axis, so here's my angle. Opposite that is here. Here's the adjacent. Here's the hypotenuse, right across from the 90-degree angle. But look what happens. Opposite is the y-coordinate, adjacent is the x-coordinate, hypotenuse is the radius. So that's why, and you can do this for the other quadrants if you'd like, and just verify that for yourself, that you will always have this, that as long as you define the angle to be what you get, the reference angle from between the terminal side and the x-axis, and you drop a perpendicular to the x-axis to create your right triangle, you will always have these definitions. That cosine is x over r, sine is y over r, and so on and so forth. Okay, so then these will fall out. Okay, now hopefully you see a difference that here there's everything is relative is to theta, but theta is always, or whatever you want to call the angle, but it's always the angle between the terminal side of the rotation and the x-axis. That's not true here when it's freeform. When it's freeform, it just depends on, well, am I talking about this angle or this angle, right? So I just wanted to make sure that was clear before we go on to another concept. Thank you so much for listening.